So far we have been dealing with specifically right triangles, but now we're going to start looking at two ways to solve non-right triangles. So if the triangle I'm dealing with does not have a right angle, I have to use what is called either the law of sines or the law of cosines to solve that triangle, which again means find all of the angles and find all of the side lengths. Some stuff from geometry that you may or may not remember is triangle congruency and things like angle, side angle, angle. Basically what you are given is going to determine which one you're going to have to use. So ones that we will use law of sines for will be side angle, angle, and angle, side angle. And the ones that we will use law of cosines will be side, 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 or side angle, side. I'll show you kind of a shortcut in how we can not even really think about those things to determine which one to use after I do the video of law of cosines. So let's say we have a non-right triangle, so I don't have a right angle here. Some of this information would have to be given ahead of time. So I'm going to go ahead and label out this information that would be provided already. Angle A is going to be 20 degrees. Angle C is going to be 25 degrees. And the side length over here between A and B is going to be a length of 80.4. So we want to solve this triangle, so we want to find the remaining pieces of information. The law of sines is essentially just setting up a proportion, and it's saying that all three of these things are equal. The sine of angle A over side length A is equal to the sine of angle B over side length B, which is equal to the sine of angle C over side length C. We're not going to use all three of those at once. We're going to use two of them at a time and set up a proportion. The first thing I want to mention is that we consider the side lengths to be the side length across from that angle. So since angle A is down here at the bottom, side length A is the side between B and C. It's the side length formed by angle A. Side length B would be the long one here, and side length C is the one that we have. So I'm going to go ahead and jump in and solve some stuff here. The first thing that you could find is angle B, right? We could find angle B. All we have to do is take 180 and subtract 20 and subtract 25, and that would give us angle B. So that's going to be 100. Let's see, I'm subtracting 45 from 180, so that's going to be 135 degrees. So I've got that. The next thing I'm going to do is I'm going to set up one of these proportions. So I didn't have to use the law of sines yet. That's convenient. But I'm going to start with the thing that I have both pieces for, which is side length C and angle C. So I'm going to say that the sine of 25 degrees over side length C, which is 80.4, is going to equal the sine of, and now I get to pick whichever one I want to solve for. It doesn't really matter. I'm going to use A, the sine of 20 degrees divided by side length A. And to solve this, I simply just need to do my cross products. So I'm going to say that A times the sine of 25 degrees is equal to 80.4 times the sine of 20 degrees. And then I'm going to divide by the sine of 25 degrees. And in a calculator, I'm just going to plug all that in. I need to make sure that I am in degree mode since my angles are given in degrees, so I am going to check that. And then we're just going to do 80.4 times the sine of 20 degrees divided by the sine of 25 degrees, and that gives me roughly 65. So side length A is going to be 65. Now, to find side length B, one thing that you cannot do that some people make the mistake of is they want to use the Pythagorean theorem at that point in time. Pythagorean theorem only applies if it is a right triangle. This is not a right triangle. Okay, so I realize that I only have one side length left to solve for, but I cannot use the Pythagorean theorem to do that. What I have to do is set up a law of sines again and use B instead of using A. So I'm still going to use the information of C because that's what was given. So I'm going to do the sine of 25 degrees over 80.4, but this time I'm going to do equals the sine of the angle B, which is 135 degrees, divided by side length B. I'm going to do my cross products again, and I'm going to end up with essentially the same thing, except this angle that I did have that was 20, now that's going to be 135. So B is going to be 80.4 times the sine of 135 divided by the sine of 25. So if I'm using a calculator, that's convenient because all I really need to do is go in here and change the 20 excuse me, to 135. And that's going to give me a side length of roughly 135, 134.5. And that is side length B. So we've solved that triangle because we found every missing side length and every missing angle. Okay, next up is an example of angle side angle. Again, a lot of this information would need to be given off the start. Again, I'm going to do triangle ABC. And this time we're given that angle A is 75 degrees, angle B is 60 degrees, and side length C is 340 degrees. So I didn't mention this yet on the other one, but what I was given was side angle angle. And what that means is I was given this side length and then an angle and then nothing again if I'm going counterclockwise here until another angle. So I'm given side, angle, angle in that order. Here I'm given angle, side, angle, right? I'm given the side that's between the two angles that is given. Unfortunately here I don't really have an option of what I have to do first. I have to find my missing angle first. Not a difficult task. I just need to figure out 180 minus 60 minus 75. And that's going to go here. The reason I have to do that is because I can't set up a proportion because I don't have a side length and the angle across from it. I don't have that given to begin with. Okay, so 180 minus 75 is going to be 105, minus 60 is going to be 45. That tells me that I have angle C is 45 degrees. Now I have an angle and the side length across from it. Therefore, I can set up my proportion. So I have that the sine of 45 degrees over 340 is equal to, pick one, doesn't matter. If we do A first, we're going to do sine of 75 over side length A. And then we're going to do our cross products. And we're going to get A times the sine of 45 equals 340 times the sine of 75. And then we're going to divide by the sine of 45, just like we did before. And we're going to do 340 times the sine of 75 over the sine of 45. I'm just going to change this information again. So we've got 340 times the sine of 75 divided by the sine of 45. And I get 464.4. 464.4. That is side length A. So this would be 464.4. You should make sure that your answers are kind of making sense as you go along. Bigger angles should lead to bigger side lengths. So angle C is 45. The side length across from that is 340. I should expect that since angle A is 75, that its side length would be bigger than 340. So make sure that that information makes sense. And then the next thing I'm going to do is, again, I'm going to solve for side length B. I'm essentially just going to replace this with sine of 60 over B. So I'm still going to have sine of 45 over 340. And now I'm going to do equals sine of 60 divided by B. Once I had side length A, I could really use A and set up the proportion with A and B and ignore C. But I always like to use the information that was given, that side length of 340. I like to use that instead, but that's up to you at that point in time. Again, cross products and then divide. So b times the sine of 45 is equal to 340 times the sine of 60, and then divide by the sine of 45. And that's going to give us 340 sine of 60 over sine of 45, so I'm just going to change my 75 to 60, and I get 416.4 this time. And that is side length B. So this is side length B, this is side length A. I do like to update my triangle as I go and kind of fill in that information, just so I can make sure that I have all of that. You could also just list it all in one location as a nice visual there. If you want to list out angle A, angle B, angle C, and then the 3 side lengths as well. Or if you just want to update your triangle, either way is fine with me. But once I have all 3 side lengths and all 3 angles, I am done. So that is one method of solving non-right triangles called the law of sines. You have to basically be able to set up a proportion in order to do that. If you can't set up a proportion, that's going to lead us to the law of cosines, which I will discuss in the next video.